Our first example of taking a derivative using the product rule. The product rule, the way I learned it, always says this. If you have f of x and you break your function into a product of two smaller parts, like a composite of two functions, you can say u times v. If you can break it down into a product of u and v, then the derivative, f prime of x, would be u dv plus v du. Now, I'll use this idea as I break all of these examples down. And so, for our first example, we have 13x squared times x minus 2 quantity raised to the fifth. As I look at this problem, the first thing I do is break it into the two parts, into the u and the v, and then I look at the derivatives. So the derivative of 13x squared by itself is just 26x. The derivative of x minus 2 raised to the fifth would be 5x minus 2 raised to the fourth. Now this comes from the previous set of examples, which would be known as the power rules. Once I have those derivatives all set up, I'm going to apply the formula that I just mentioned a second ago, which was the u dv plus v du. I will go u dv plus v du. So it's just kind of like a cross tabulation there. First couple examples I'll use this, and then I tend to get away from this so that we just work it out. We don't need to write this every time. It's a nice tool to use as you first try to take these derivatives. And so, for my first derivative, again, it's going to be u dv plus v du, and all I do is plug that stuff in there. 13x squared times 5x minus 2 raised to the fourth, plus, here's my v, x minus 2 raised to the fifth times 26x. From here I notice that there is a set of common divisors, or you can say greatest common multiples. I can pull some common factors out, and as I pull those common factors out from the first set, I notice that I can pull a 13x here and a 13x there. They both have this x minus 2 raised to a power. In fact, it's raised to the fourth power, or at least the fourth power in each of these. And so I pull that out as 13x times x minus 2 raised to the fourth. Then I see what's left over. For this first one, I'm left with a 5 here and an x from the 13x squared. And so that's where this 5x comes from. From the second set of terms, I notice that I'd be left with a 2 from the 26x, and I would be left with an x minus 2 from the x minus 2 raised to the fifth. If I distribute this, I can write it as 13x times x minus 2 raised to the fourth. 5x plus 2x is 7x, and 2 times negative 2 is negative 4. So I left this in the bracket to show that I've simplified what was originally in this bracket here, and I successfully went from a sum of products into products of sums or differences. And that would be the example for using the product rule. Most generally, this is what you get down to, into a series of products.